This video is to help you with the classwork for section 1.1.3, how does it grow, describing and extending patterns. Our learning target is to extend a pattern and generalize it in order to make a prediction. So they remind you that patterns are everywhere, that you might have noticed them in pine cones, flowers, stacks of cans in the grocery store, or many other places. Patterns are interesting partly because of the different ways you can see how the parts of a pattern are changing. In this course, you'll often be asked to look for different ways of seeing a pattern or a concept. All right. So what we're going to be starting with is this dot pattern. They want you to start by copying this dot pattern onto graph paper, and then they want you to be able to look at the pattern and figure out what the fourth and fifth figure would look like. All right. So as you do this, one thing that might jump out to you is that you always have the same 3 dots here on the end. But then what happens is we're adding a set of 1, 2, 3, 4, 5 dots. One of those for figure 1, 2 sets of those 5 dots for figure 2, 3 sets of those 5 dots for figure 3. Now this may not have been how you would have seen the pattern if you looked at it, but it is one way to view it. So when you look at drawing figure 4 and 5, they should look like this. Again, the one set of 3 dots here on the end, and then we're adding the 4 sets of these 5 dots, making sort of a backwards letter C if you want to think of it that way. 4 sets of those for figure 4, 5 sets of those for figure 5. Okay. Again, it's definitely not the only way to view it, but it is one way to view that pattern. So then when you want to describe how the pattern is growing, you should think about how you can write that in words. All right. So one way to do it would be to look at how many dots are in each figure. Okay. And most people have an easier time with this because they can see the pattern of, okay, I'm adding 5 dots each time. But the challenge to that is if you're asked how many dots are in a certain figure number. So in other words, the challenge is how do you figure out how to get from the figure number to the number of dots without having to do all of the previous? In other words, if you want to figure out the 10th figure, is there a way to do it without figuring out the previous 9? Okay. And if you want to figure out how many dots are in the 30th figure, is there a way to figure it out without figuring out the previous 29? All right. So what we had put for this is that one way to think of it is that figure 1 has these 3 dots plus 1 set of 5. Figure 2 has these 3 dots, again in green, plus 2 sets of 5. Figure 3 has 1 set of 3 dots in the green and 3 sets of 5. So therefore figure 10 would have the 3 dots in the green and then 10 sets of 5, or in other words 53 dots. And figure 30 then would have 3 sets of dots, or the 3 dots that we highlighted with green, and then 30 sets of 5. So 30 times 5 is 150 plus 3, 153 dots. So again, it's not the only way to think of it, but it is one way to think of it. All right. When you look at 118 and you're looking at this dot pattern, again, the idea is how can we visualize it in multiple ways? So figure 1 has 1 dot, figure 2 has 2 dots and then 1. Figure 3 has 3, then 2, then 1. So figure 1 is 1 dot, figure 2 is 2 plus 1, figure 3 is 3 plus 2 plus 1. So figure 4 would be 4 plus 3 plus 2 plus 1. Figure 5 would be 5 plus 4 plus 3 plus 2 plus 1. Okay, and then you could count that up to figure out how many dots. From that, you could then predict how many dots would be in the 10th figure. So it'd be 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Now, instead of putting that into a calculator, you can look at the fact these are basically numbers that are consecutive. They are going down in a consecutive fashion, meaning 10, 9, 8, 7, 6, 5, 4, and so forth. So where I got this 5 times 11 from is that if you took 10 plus 1, you get 11. If you take 9 plus 2, you get 11. 8 plus 3 makes 11. 7 plus 4 makes 11. And then 6 plus 5 makes 11. So if you look at these as pairs, 10 and 1 making a pair of 11, 9 and 2 making a pair of 11, and so on, you have 5 pairs of 11 or 55 dots. That definitely helps when you want to figure out how many dots would be in the hundredth figure. Because if you look at that pattern, it'd be 100 plus 99 plus 98 plus 97 plus 96 plus 95, all the way down to 3 plus 2 plus 1. Well, you don't want to put that into your calculator. You know, just about the time you get to maybe 65, you're going to end up making a mistake when you put it in the calculator and having to start all over. So instead, using this sort of, mathematical technique, you can make this much easier because you can say, all right, well, I know 100 plus 1 would be 101. I know 99 plus 2 would be 101. I know 98 plus 3 would be 101. So each pair would make 101. How many pairs of numbers are there between 100 and 1? There are 50 pairs. So 50 times 101, 5,050 dots. All right. So that is basically the main concepts from the classwork from section 1.1.3. Thanks.